Hello everybody, myself Adarsh. I had created this video in order to show the execution of the stepper motor using Keel software and stimulation part in Proteus software. Let us create one folder in order to store our all files. I am going to name this folder name as stepper motor, and in order to write my code of the stepper motor I am going to use the Keel software and create the new project. I am going to store in the desktop. Folder name is stepper motors and the file name is stepper motor, and I'm going to run this stepper motor code by using the microcontroller chip, and I'm going to use the microcontroller chip name as 8089 C51 atmel, and then I'm going to create the new file, and the header file of the 885 C51 is hash include reg51.h. We know that the microcontroller chip pin configuration, I'm going to use the P1 pins for the each bit initialization: P1, P10, P11, P12, P13. Yes, bit. The pin name is pin name of first bit P1, pin name of first pin, the bit 1 is mod 1 equals to P1, P1 cap 0. Yes, bit mod 2 P1 1. Yes, bit mod 3 P1 cap 2. Yes, bit mod 3 equals to, sorry, mod 4 equals to P1 cap, P1 cap 3, because the stepper motor has the 4 pins, so the 4 bits of the P1 I'm going to use, where the when the 4 bits, in the 4 bits, when I'm going to assign one bit as high and another 3 bit low, that the high bit makes the stepper motor to run either in clockwise or anti-clockwise. I'm going to run in main. I'm going to write the main function unsigned int I. I'm going to initialize all the mod pins 0, 2 equals to mod 3 equals to mod 4 equals to 0. I'm going to make each pin now high, so that to run the bits, to run the stepper motor equals to 0, I lesser than 60,000, I plus plus. This is the delay what I'm going to give to make the each bit high. Mod 1 equals to 0 for I equals to 0, I lesser than 60,000, I plus plus. This is the next delay to make the M2 to high. Before, sorry, this is M1 is high, and here I'm going to make M1 0 and M2 to high equals to high for I equals to 0, I lesser than 60,000, I plus plus. This is the next delay to make the M3 to high. Before going to make M3 to high, I'm going to make M2 to 0, mod to mod 2 to 0 and mod 3 to high, and then I equals to 0, I lesser than 60,000, I plus plus. Now I'm going to make M4 high. Before going to make M4 high, I'm going to make M3 low, mod 3 equals to 0, mod 4 equals to high. For next I'm going to make M4 0, I equals to 0, I lesser than 60,000, I plus plus, mod 4 equals to 0. This is the code. This is this, and now I'm going to make the infinity loop. So while make it to 0, and I'm going to save this. Stepper motor 1, stepper motor dot c. Now I had saved this, and then after saving I'm going to compile this. 0 errors and warnings. There is no impact on the warnings. Let us see that whether our hex file is created or not. In the stepper motor folder, object, oh, stepper motor hex file is not been created. Let us see what had happened. Hex file is being created. Okay. Now I'm going to run this in Proteus software, new, I'm going to choose the file desktop, stepper motor, select the folder, next. Now I am going to use 8085C51 as a microcontroller. 8089, sorry. And then another, we need a stepper motor. Stepper motor of bipolar, and I'm going to dump it on the Proteus software, and I'm going to connect all the pins P1, P2, P3, and I'm going to dump the code for this. The frequencies is 11.0592. The folder is, the hex file is not being created. I think it is stored in the folder documents, new, kill, and stepper motor. Here is our hex file. Actually, the storing of the hex file will be done in, I had stored the hex file uh, in the documents, so the it is not showing in the desktop. The code is being dumped. Let us run it. It's running successfully. Thank you for watching my video. It's rotating. The Now the P2 pin, P1 pin of the 1 bit is high, and then P3 will be high, and then the sorry P1 of 3 will be high, and again the infinity loop is being created. P1 of 1 bit is high, and then P1 of 2 bit is high, and then P1 of third bit is high. Thank you. Let me off my video.